Thank you very much, ma'am. It's my honor and privilege to introduce today's chief guest, Mr. Achyut Godbole, sir. The first, I think, it doesn't require any kind of introduction, as he is a very notable person in the industry, in all the industries. But he belongs to Solapur. This is the first introduction. आणि त्यामुळेच मी मराठीमधून थोडंसं त्यांचं इंट्रोडक्शन देण्याचा प्रयत्न करतोय. कारण मंगळूर कॉलेजमधून आणि सेंट जोसेफमधून काही विद्यार्थी इथे आलेले आहेत. आजच्या या कार्यक्रमासाठी आपल्याला लाभलेले प्रमुख वक्ते माननीय अच्युतजी गोडबोले सर यांचा परिचय करून देण्याची संधी मला प्राप्त झाली. त्याबद्दल सर्वप्रथम आयोजकांचे मी आभार व्यक्त करतो. माननीय अच्युत गोडबोले सर हे शालांत परीक्षेत म्हणजे 10वीच्या बोर्डाच्या परीक्षेत राज्यात 16वे आले होते आणि तसेच संपूर्ण विद्यापीठामध्ये त्यांचा 16वा क्रमांक आला. संपूर्ण विद्यापीठात त्यांचा पहिला क्रमांक आला होता. पहिलीपासून ते IITच्या परीक्षांमध्ये सर्वोच्च गुण आणि पारितोषिक सरांनी मिळवलेली आहे. IIT मुंबईचे केमिकल इंजिनियर ही पदवी त्यांनी संपादन 1972 साली केलेली आहे. सॉफ्टवेअर क्षेत्रात भारत, इंग्लंड आणि अमेरिका इथं 32 वर्षाचा सरांचा अनुभव आहे आणि त्यातली 23 वर्ष हजारो सॉफ्टवेअर इंजिनियर्स असलेल्या जगन्मान्य आंतरराष्ट्रीय कंपन्यांमध्ये MD, CEO अशा सर्वोच्च पदांचा अनुभव सरांचा आहे. आतापर्यंत सॉफ्टवेअरच्या कामानिमित्त सुमारे 150हून जास्त देशांमध्ये सरांचा प्रवास झालेला आहे. जगामध्ये 150 पेक्षा जास्त देश सर फिरून आलेले आहेत. त्यानंतर पटनी, सिंटेल, एल इन्फोटेक, L&T, अपार, दिशा अशा मोठ्या कंपन्यांच्या सर्वोच्च पदी असताना त्यांच्या जगभराच्या अनेक पटींच्या वाढीमध्ये सरांचा हातभार आहे. 7 हिल तर्फे जगभर वापरल्या जाणाऱ्या कम्प्युटरवरचं टाटा मेग्रा या ऑपरेटिंग सिस्टीम्स, डेटा कम्युनिकेशन्स अँड नेटवर्क्स, वेब टेक्नॉलॉजीज आणि डिमिस्टिफाईंग कम्प्युटर्स याच्या प्रत्येकी 500 ते 700 पानी पाठ्यपुस्तकांचं लेखन चायनीज आणि इतर भाषांत देखील म्हणजे ती पुस्तकं अनुवादित झालेली आहेत. आत्तापर्यंत सरांचा जो परिचय आहे तो आपण एक सॉफ्टवेअर इंडस्ट्रीमधला एक एक्सपर्ट या उद्देशाने आपण बघितलं. परंतु त्या सरांची एक अजून एक वेगळी ओळख म्हणजे सर हे खूप मोठे लेखक आहेत आणि आत्तापर्यंत मराठीत लोकप्रिय अशा 54 पुस्तकांचं रायटिंग सरांनी केलेलं आहे. त्याच्यामध्ये विज्ञान या विषयावर किमयागार नावाचं एक पुस्तक सरांचं प्रसिद्ध आहे. जिनियस भाग 1, भाग 2 आणि 3 जगप्रसिद्ध अशा पाश्चिमात्य भारतीय शास्त्रज्ञ आणि तंत्रज्ञ यांच्यावरची 9 पुस्तकं आतापर्यंत सरांची प्रकाशित झालेली आहे. रक्त, विटामिन्स, सूक्ष्म जंतू, शरीर, हवा, वैद्यकायन आणि षड्रिपू म्हणजे माणसाला भेडसावणारे 6 मुख्य विकार यांच्यावर देखील सरांचं लेखन झालेलं आहे. तंत्रज्ञान या विषयावर संगणक युग, ज्ञानोदय, आर्टिफिशियल इंटेलिजन्स, इन्फोटेक, डेटा सायन्स, इंडस्ट्री 4.0 to 5.0, फ्युचर टेक, भन्नाट शोध, मानवी जीवन सुकर करणाऱ्या शोधांची कहाणी अशी एकूण 8 पुस्तकं विज्ञानावर प्रकाशित झालेली आहेत. गणित या विषयावर गणिती, संख्या आणि स्टॅटिस्टिक अशी एकूण 3 पुस्तकं प्रकाशित झालेली आहेत. तंत्रज्ञानाचा इतिहास, बखर संगणकाचा इतिहास, संवाद, कम्युनिकेशनचा इतिहास, प्रवास, प्रकाशतंत्र अशी 4 पुस्तकं देखील तंत्रज्ञान या विषयावर सरांची प्रकाशित झाली आहे. इतिहास या विषयावर गुलाम, अन्न अशी 2 पुस्तकं इतिहास या विषयावर प्रकाशित झाली आहेत. अर्थशास्त्र या विषयावर अर्थात अनर्थ अशी 2 पुस्तकं, कायदा या विषयावर माय लॉ असं एक पुस्तक, व्यवस्थापन या विषयावर बोर्ड रूम हे पुस्तक, चरित्र आत्मचरित्र विक्रमी कपाचं जे पुस्तक मी देखील वाचलेलं आहे. विक्रमी कपाचं मुसाफिर नावाचं आत्मचरित्र, स्टीव्ह जॉब्स यांचं चरित्र देखील सरांनी लिहिलेलं आहे. मानसशास्त्र सरांचा अत्यंत आवडता विषय आणि त्याच्याबद्दल मी सर्वात पहिले वाचलेलं पुस्तक म्हणजे मनात नावाचं एक पुस्तक सरांचं अत्यंत सुरेख आहे. मनकल्लोळ 1, 2 मनोविकार, ऑटिझम म्हणजे स्वमग्नता, नैराश्याबद्दल सर्व काही, सायकोथेरपीज, थैमान चंद्रवाताचे, अशी एकूण 6 पुस्तकं मानसशास्त्र आणि त्या विषयावर सरांची प्रकाशित झालेली आहे. संगीत, चित्र, शिल्पकला, चित्रपट, साहित्य या विषयावर नागवेद, भारतीय संगीत, सिम्फनी, पाश्चात्य संगीत, कॅनव्हास, चित्र, शिल्पकला, लाईमलाईन, विदेशी चित्रपट, सपूर्जा 1, 2 आणि 3 अशी एकूण 7 पुस्तकं सरांची आतापर्यंत प्रकाशित झालेली आहेत. आणि एवढंच नाही तर प्रकाशनाच्या वाटेवर असलेली 11 पुस्तकं देखील सध्या येऊ घातलेली आहेत. इन्फॉर्मेशन टेक्नॉलॉजी, विज्ञान, तंत्रज्ञान, गणित, संगीत, साहित्य, कला, अर्थशास्त्र, राज्यशास्त्र, तत्वज्ञान, मानसशास्त्र आणि फ्युचरिझम या विषयामध्ये रस आणि यावर टेलिव्हिजन आणि यूट्यूब यांच्यावर अनेक भाषणं आणि चर्चामध्ये देखील सर सहभागी झालेले आहेत आणि सरांच्या मुलाखती देखील आपण यूट्यूबवर पाहिले असतील. IIT तर्फे 2दा पुरस्कार, MB पंतप्रधानांकडून 2दा पुरस्कार, उद्योगरत्न, प्रचंड बहुमानाचा ITI डिस्टिंग्विश्ड ॲल्युमिनस पुरस्कार, पंडित भीमसेन जोशींच्या हस्ते कुमार गंधर्व पुरस्कार, तसेच संगीत, विज्ञान, तंत्रज्ञान, मानसशास्त्र आणि अर्थशास्त्र या क्षेत्रातली कामगिरी आणि पुस्तकं असे अनेक मानाचे पुरस्कार, साहित्य परिषद, सोलापूर विद्यापीठ याचबरोबर 5 मान्यवर संस्थांकडून असे एकूण 7 वेळा जीवनगौरव पुरस्कार सरांनी प्राप्त झालेले आहेत. त्यांच्या लिखाणावर 2 जणांची PhD सुरू आहे. टेडेक्स या प्रचंड प्रतिष्ठेच्या भाषण मालिकेत भाषण देण्याचा सरांचा बहुमान आहे. 2015च्या अमेरिकेच्या बृहन्महाराष्ट्र मंडळाच्या लॉस एंजेलिस इथं झालेल्या तर 2019 साली ऑस्ट्रेलिया इथं झालेल्या संमेलनाचे सर प्रमुख पाहुणे म्हणून राहिलेले आहेत. महाराष्ट्र साहित्य परिषदेच्या युवा साहित्य नाट्य संमेलनाचे अध्यक्ष देखील सर राहिलेले आहेत. आशियाना नावाची एक ऑटिस्टिक मुलांची चळवळ, स्वमग्नता, ऑटिझम इज वन ऑफ द डिसीज, आणि त्यासाठी आशियाना नावाची एक मुलांची शाळा देखील सरांनी सुरू केलेली आहे. त्यानंतर IITचं आपलं शिक्षण झाल्यानंतर भिल्ल आदिवासी चळवळीत देखील सरांनी सहभाग नोंदवलेला आहे. सध्या सॉफ्ट एक्सेल कन्सल्टन्सी सर्व्हिसेसचे मॅनेजिंग डायरेक्टर म्हणून सर काम पाहत आहेत. असं हरहुन्नरी व्यक्तिमत्व, मल्टी डायमेन्शनल पर्सनॅलिटी आपल्याला आज इथे लाभलेली आहे. सरांचं NB सिंहगड अभियांत्रिकी महाविद्यालयाच्या वतीनं तसेच सिंहगड इन्स्टिट्यूटच्या वतीनं मी सरचं स्वागत करतो आणि पुढची
Modern services is from 1960 onwards, computing, banking and insurance, modern banking insurance started taking shape. So the progress that we made in the last 2 decades was much higher than the progress that we made in the 2 centuries of industry, which in turn was much higher than the progress that we made in tens of thousands of years of agriculture. So that's how I'm sure your engineering students have done mathematics. So if we talk about D2I/D, the rate of change itself is very high. It's not dy/dx that we're talking about. It's the rate at which the technology is changing is very, very, very high. Now, if you look at the services decades, the 1960s was the decade of mainframes, 1970s was the decade of mini computers, 80s was the decade of personal computers, 90s was the decade of internet, 2000 was the decade of mobile computing, and 2011 onwards was the decade of Industry 4.0, and I'm going to talk about that. Out of which artificial intelligence is one of the most important components of Industry 4.0. In 2017-18, there was an announcement of Industry 5.0. All of them happened in Germany, in Frankfurt, where I visit very often. But I think the important thing is, how did it take place? Let's just trace the history a bit. Then I'll talk about the future. That's what I'm going to concentrate upon. 1960s was the decade of mainframes. Mainframes were very large. A mainframe computer used to occupy a room as big, half as big as this. The rooms were air conditioned and they were very big. They used to emit heat. They were not reliable. And they were very expensive. They were not user friendly. There was no mouse, there was no GUI, graphical user interface. There were not colors in the computers. So it was very difficult to use the computers. They were not user friendly. So people used to be frightened about using the computers. users were frightened. They were punch cards. They were not terminals. They were, but I think they were very few, far between. So basically, the computers used to run on punch cards. And programmers used to go around with punch cards and feed the data, type punch the data on the punch cards, then feed the punch cards to the computer, and then run the programs and take the reports out. People outside used to look at the computer with awe and fear as what was happening inside. They were not understanding what was happening. There were only two places that people used to remove their chuckles. One is the computer room and another is the temple. Because in both the places they did not understand what was going on inside and how the decisions were made. It was much safer to remove the chuckles than go inside. Users did not trust the computer because it was batch processing. Anything you had to do, you have to put the data on the cards, punch the data on the cards, feed the cards to the computer. Computers to read that data, the process, and the reports used to come out. But before that, you have to make sure that the data was punched correctly. So the punch cards have to be fed, the computers will do the listing, then users have to check whether the listing was correct or not. Make corrections, then the wrong cards have to be repunched and the data have to be fed until such time that the data was correct and then the reports used to come. So it used to take a long time until by the time the reports used to be in the hands of the users. So users were not very happy. There was no real-time processing. Today we press a button and then suddenly a seat is booked to the airlines or hotels or whatever at that moment itself. And somebody else wants to book the same seat in the theater or restaurant or whatever, you can't because that seat is booked. It's real-time processing, online, on terminal and keyboard itself. That was not the case then. There was batch processing. You could compare the data feed and then the reports would come late. So users were very annoyed with this kind of thing. I remember when I was in IBM, we had to go to the users and then say, I'm an IBM, we'll write programs for you, so please give us a contract or project. And the users used to be annoyed because manually we get the reports far faster than your computer reports. That's what their complaint was. So it was very hard. Then came the decade of mini computers of 1970s. The prices fell, the power increased, there were terminals, but there was no real-time processing yet. Databases had started emerging. Communication started taking place within the computer family. Like IBM, if there were 10 IBM computers, they could communicate with each other with a protocol which is called SNA. I don't know, some of you may be aware, but there was a communication protocol for IBM computers to communicate to each other. Similarly, there was a protocol for digital equipment, they, prime, bank, etc. All many computers could talk to each other with that protocol. But there was no, the prime computers could not talk to IBM, IBM computer could not talk to digital equipment corporation, and so on. So there was still a lot of progress that had to be made. Then came 1980s. 1980s was the era of personal computers. And that changed everything. Because personal computers, with personal computers, the prices fell, the power increased tremendously, and then you could see the personal computer, the desks of hundreds of thousands of people suddenly. Of course, took 4 or 5 years by the time the prices fell and people started accepting PCs. There were colors for the first time. There was multimedia. You know what is multimedia? Text. When you type A to Z, or 0 to 1, it is stored in zeros and ones on the disk, in bits, right? Photograph, a digital photograph, to a mobile, when you take a photograph, it's stored in zeros and ones in a mobile, which is again essentially a computer. Or a video, also is stored in zeros and ones. Earlier there were DVDs, if you remember, and now in mobile, when you take video graphic, that's stored also as zeros and ones. So text, audio, and audio also. Music also is stored in zeros and ones. So these four formats, text, audio, video and photo, or digital photograph, are stored on zeros and ones and could be transmitted, could be deleted, could be modified, unfortunately to bad, to really unwanted results. But when all these four formats could be stored in digital format, that's called multimedia. So when personal computers came, there was multimedia, there were colors, there was graphical user interface, there was mouse, and there was real-time processing, and then suddenly computers started being used by people because they started trusting computers for the first time. They could handle the computers, they could actually use the computers. Lawyers, professors, engineers who actually did not have the opportunity to use computers by then. They had to depend on programmers to go to the computer room, feed the data, and to take out the results and then give the results. Here they could operate the computers themselves. So they started trusting the computers. And then information technology, which is the combination of computers and communication both, IT revolution really began in 1980 onwards. And information technology started attacking or growing from almost every walk of life. And that changed just about everything. That changed the way we did things. The most important thing is, and that is the essential thing that I'm going to repeat again and again throughout the lecture that I'm giving you, is that the way you do things, the way we did things, changed tremendously at a very rapid rate. I'll give you some examples. For instance, earlier, there were teller clerks in the bank. When you wanted to deposit cash or withdraw cash, you used to go to the bank and then you used to be given a token. You had to wait and then your turn came and then you went to the counter and then you could deposit the cash or withdraw the cash, right? With ATMs, all that vanished. There was no need for teller clerks at all. You could yourself go and withdraw the cash, deposit the cash. So what did teller clerks do? The teller clerks were jobless. Unless they unlearned and learned, and that's the theme I'm going to return again and again. Unlearned and learned something new, they were jobless. Because now the technology rendered all the teller clerks jobless. They had no role to play around. Take CAD-CAM. With CAD-CAM, earlier, there were draftsmen who used to take T-square and do the drawing, machine drawing. In IIT, we used to have T-square and we used to do machine drawing. Of course, we didn't do it. Somebody else had done it 10 years ago, and we always do copy. It's called a GT, glass door. I'm sure you know that. But somebody had to do it. With CAD-CAM, you didn't have to, you certainly did not need a T-square, and on sitting on the computer, you could actually draw, design, and in fact, also do the finite element analysis and so on, which can go to the production. So what did the draftsmen do? They were jobless unless they learned the tricks of CAD-CAM. Similarly, earlier there were typists. Every nook and corner of the city, there were typists. And you could go and give your material, and the typists used to type your material with carbon copies and so on. And the roller had to go to one end and used to make some sound, and the roller had to come back for the next line and so on and so forth. With word processing, all that vanished. The typists, all hundreds and thousands of typists were jobless unless they learned the tricks of word processing. Word processing is a tremendous amount of facilities, right? Paragraphs and bold and italics and hundreds of things. Pagination. Unless they learn how to operate the word processor, the typists were jobless. And then came DTP, desktop publishing. Desktop publishing is still a further version of word processing. Without desktop publishing, you cannot have today any newspaper industry, no book industry, no publishing at all, nothing. It's impossible. So basically, I'll give you an example. Earlier, when a newspaper used to be printed, the last night, in Marathi, you have to set all the characters on the page, and page by page you have to print. Right? But with DTP, you could move pages, figures, images, or text from one page to another in minutes. How does it help? Supposing at 10 o'clock in the night, you get the news that an American president has been assassinated. Earlier, you could do nothing because the page had been set. To redo the page would take hours together. You could obviously miss the target deadline of releasing those pages for printing. But immediately, within minutes from the internet, you can call out the news of the American president being assassinated, the photographs and the text and so on, and put that on the front page. What was to be printed on the first page, you can move to the third page immediately within minutes, and the new format of the newspaper is ready within absolutely half an hour to an hour. And the next morning, you get a paper where the news of the American president being assassinated last night appears on the first page. If the newspaper says that not only uses new technology of DTP, but other newspapers use it, that newspaper will be thrown out of the market. So for the first time in 1980s, IT, information technology, made a very bold statement to businesses. What it said earlier, we used to go to business and say, please give us some work, I will automate it, that I will reproduce what we do manually, I will mimic what we do manually, and reproduce the same thing on computer, then you pattern by pattern. That was our USP, that was our statement. Now, the information technology started telling businesses, I'm not going to reproduce what you do manually, I'm not going to mimic you. You better use me and reorganize your business to improve your efficiency. If you don't do that, you will be thrown out of the market or competition. So IT became central. Information technology became central around which all the businesses were organized. IT did not remain a tertiary or a nice thing to have also sitting in a corner. But IT started becoming central to any business, and that's what the most important thing that happened in 1980. And that changed everything. Similar, as I said, DTP, that happened in every business. Once animation, Walt Disney had employed hundreds of artists in his garage. Walt Disney had employed hundreds of artists in his garage. When you want to show a cat moving from one end of the wall to the other end of the wall, with animation, still Tom and Jerry, whatever, how do you show it? One artist used to draw a picture of the cat at one end of the wall, then another picture with the cat having moved a little bit, then the third picture with the cat having moved still a little bit, and so on and so on until the cat reached the other end of the wall. Then shoot those pictures and put them on this, and then show the reel at more than 10 per second. Why more than 10 per second? Because the quality of our retina is that any picture is retained on our retina for 1/10 of a second. So before the first one fades away, the second one falls on your retina. The second one fades away, the third one falls on your retina. It gives an impression that it's a continuous motion. It cheats your eyes basically. So you feel as if there is a continuous motion of the cat running from this end of the wall to the other end of the wall. So basically, there were hundreds. Imagine for 10 pictures in 1 second. So for 1 minute, 600 pictures, and for 1 hour of Tom and Jerry picture, 36,000 pictures. But you didn't have to redraw from the beginning, and there was tricks that you could use for tracing and so on. But even then, it was non-trivial efforts. So you had to employ hundreds, in fact, of artists in the garage to keep on drawing those pictures and shoot them and show them and produce a Tom and Jerry animation film. Then came in 1980s a software which is called in-between. The software said, give me a picture of the cat at this end of the wall, give me another picture of the cat at the other end of the wall, and in between the pictures, I will draw. There is software using graphics and so on. I don't know the graphics, rotation and algorithms and so on. The software said that I will draw the intermediate pictures for you. And then all the artists were jobless. Then came 3D animation. Now no advertisement, no film can be made without 3D animation. Because a Colgate toothpaste suddenly takes a flight and then falls in the hands of another American or whatever. Now Newton will rotate in his grave, I to talk about gravity and how can Colgate toothpaste jump and fall in the hands of somebody else. But with animation you can make anything happen. So basically, no advertisement or no films can be made without animation today. So just understand, earlier it was a nice thing to have. If you have computers, maybe you'll get reports faster, you'll get accurate reports. It is nice to have. Maybe they have to justify the investment. Now there was no question of justification. You better use me, otherwise you will perish. That was the mantra of 1980s. That's why in America, most of the industry, most of businesses started using computers and reorganizing their businesses around information technology. Management departments, it's called the Business Process Engineering, BPR. I was there in the US at that time when the whole BPR revolution was taking place. General Electric was leading at that time. And all businesses started using computers and information technology, redesigning their systems in America. America, in these matters, America takes the lead. Which is why in America there was a tremendous shortage of programmers. The price or the rate at which programmers were available at that time in America was $150, $120 per hour, US dollars per hour, which in today's terms would be 10,000 rupees per hour. So 8 hours, 80,000 rupees per day. Not a bad money, but that's what the businesses had to share out. That's when I was in Patni then. Narayan Modi had left Patni and started Infosys. I sat in the same chair and ran Patni for 11 years. So I was there in Patni, then Narayan Modi, Nandan, several other people used to go to America, and then our selling point was the why is spending $120 per hour to an American programmer who's a school dropout. I will send you an engineer, trained engineer, to you. I will pay for the airfare, I will pay for the hotel charges, so all that, and I will only charge you $60 to $70 an hour, and still I will make profit. That was the selling point of Indian companies. Even then, American companies did not pay heed to what we were trying to say, because the American channels had created the image of India in such a fashion that everybody thought that we have circumstances, elephants and magicians. But the first time I got a chance to talk to an American businessman, a presentation after trying very hard for several months. But I remember having called American companies, it was snowing outside New York, Manhattan. Nobody gave me meetings because the impression of India was so poor. It was things and magicians and elephants and so on. The first time I got a meeting, I said, we also have IITs. They said, what is IIT? They didn't know what IIT was. And then, of course, they gave us a chance, and then I sent 2 people to America with a condition that if they don't work out, they will be sent back in 15 days and so on. And then they worked out beautifully, then they sent me 2 more and 2 more and so on. The same thing happened in Infosys, TCS, TU, etc. And in 1980s, 100,000 people went to America. I myself sent thousands of people to the US. They worked wonders, and the credibility gap was built or bridged. And then 1990 was the era of internet, and therefore we said, why do you want us to send people from here to America and spend money on airfare and so on and so forth? They can work from here through satellite links, because internet had come about by then. And then we started working from here. That's when the entire Pune, Injewadi, Delhi, Calcutta, Chennai, and all those centers came about, and then India developed into IT hub. That's the history. Then 2000 onwards, mobile computing took place, and 2011 onwards, Industry 4.0 was announced in Hanover in 2011 in Germany. Now I will talk about what is Industry 4.0. Industry 4.0 essentially, I will talk about Industry 4.0. Industry 4.0 essentially, today everybody is talking about Industry 4.0 because that is going to dominate tomorrow's world. Industry 4.0 comprises 8 major technologies. Artificial intelligence is the most important part of Industry 4.0. And other technologies are IoT, IIoT. IoT is the Internet of Things, and IIoT is Industrial Internet of Things. Then big data, then augmented reality, virtual reality, then cloud computing, 3D printing, 5G, and so on. All these together is Industry 4.0. Out of which artificial intelligence is the most dominant part. That is Industry 4.0. Now in 2017-18, Industry 5.0 has been announced. I will talk about what that concept means. I'll tell you how it works so that you get an idea about how it works. And then I'll talk about what the future is, what is in store for us in the future is concerned. Before even AI came into existence, in 1996, Bill Gates wrote a book which is called Business at the Speed of Light. And at that time, had an enormous foresight. And I really salute it. The book is so good that it couldn't have been written by Bill Gates. But anyway, whoever wrote it, the book is extremely good. What it said was very prophetic. Though everything is not taken sort of come about as of now. But I can see that in the next 10, 20, 30 years, when you are also in the midst of your career, most of the things that I'm talking about will actually come about. So please understand what I'm talking about. First, all notes, credit card, debit card, checkbooks, all of those will vanish. Today, we know that this is going to happen. When I used to talk about this 15, 20 years ago, people used to look at me with disbelief. So they didn't believe me. But today, Paytm, GPay, etc., you don't need all these things. In China, these things hardly exist. If you work, then you are paid, which means your bank balance is increased, in accounting terms is credited in zeros and ones. When you spend that money, you go to a shop and buy a shirt, it is debited. Your balance will be decreased in zeros and ones by that amount. So, why do you need checkbooks and so on and so forth? You don't need them at all. Second, all offices, here is careful. All offices will become museums. All offices will become museums. There is no need to have any office at all. You can sit at home, maybe I'm a CEO and I have 4 directors of marketing, South, West, North, etc. They are sitting in their respective homes and there is a screen, there is a video camera and each one is talking on each screen at the center I am visible and at the 4 corners there are 4 managers. And you can discuss and talk. On the television today, every minute, every hour, there is a discussion, one from Canada, one from UK, one from US, etc. Why do you need to travel? All data can be shared. You need to sit at home and then discuss and talk and fight or whatever, or take decisions. Please understand that the tyranny of travel will vanish. I have several books about death of distance, which means that you don't need to travel. If you want to travel to meet your friends, or playing chess, or swimming, for walks, or whatever, or music concerts, you can go. But you don't have to go to work. That is all offices will become useless. That will have enormous impact on real estate prices, for instance. Not immediately, but wait for 10, 20, 30 years. So all of you, when you are in the midst of your career, these things will happen and these things will have a tremendous impact on the way we live. Now, that's what happens also in the schools and colleges. You don't need all this. Most of the things that you teach today, somebody writes on the board and the students taking down, all that will go. And now even today, people just take mobile pictures like this when the teachers write. All that will go because there will be videos about most of the subjects which are far better. And the teacher's role will be to produce very good videos and to facilitate solving problems for students, rather than school filling every step, writing on the board and the students taking that, rotating out. So education is going to undergo enormous amount of change, and that's what happens in every field. But the most important thing that Bill Gates has said in that book is that all the intermediaries will vanish. All the intermediaries will vanish is going to have tremendous impact on the way we do things and employment. I'll give you an example. Take travel agents. Earlier, you could go to travel agents and cut tickets. Right? Now you don't have to go to travel agent for ticket. On the internet you can book your ticket, railway, bus, whatever. So the travel agents, only those who have survived have reorganized themselves. Then I'll take a tour, I'll give you a guide, I'll book the hotels, and all that. I'll put together the package. And only those who offer those packages have survived. All the rest who could only cut tickets have vanished. Similarly, take bookshops. Every week there are several bookshops in the world which are closing down. Why do you need a bookshop? Where you can order from Amazon, you can order from the publisher's website. You don't need to go to a bookshop at all. So we can, this is home delivery. You can get a book. And similarly, you can get them just about everything today, sitting at home. You don't need the shops which display of the trousers and shirts and so on and so forth. Because with augmented reality, you can sit at home, you can choose Raymond's or Louis Philippe, whatever brand you want, and then say, my size is this 42, 40, the color is blue, and then I have half shirt, etc. And then you can, sitting at home, check how it will look on you without even touching it. That's augmented reality for you. So why do you need these hundreds of shops? Why do you need people selling those? It will completely change the economic patterns. Similarly about shoes. Similarly about the tiles. You know, I'm sure you must have seen the advertisement. On the mobile, it gives you an option. Which tile you want. So you choose a particular option and then put the mobile on the floor and it will show you how your floor will look like with a particular tile that you have chosen. And say, no, that's not very good. Let me choose another one. So it will show you with that tile how to do. And after that you choose the purchase directly from the producer. You don't need all the shops which display all those tiles. Similarly about furniture. IKEA is a company which actually allows you to check how particular furniture will look like in your hall or whatever. You give your. Is there a problem? So you give the demand. No, you. If you give the dimensions of your hall or a room, it allows you to see how a particular table, a chair, or a particular furniture will look in your room. And then you choose. You don't need to actually go to a furniture shop and then choose and then bring that to your house and then only to repent or maybe return and so on and so forth. So all these shops, all the intermediaries, whether it's furniture, paint, jewelers, and many other paint companies actually allow you to see on this wall I have red, I have green. This is a bad choice by the way. But I mean, if somebody chooses some color combination, you can watch, you can see how a room will look like using those colors without even touching the paint. And then order directly from the producer. You don't need all the shops displaying all those paints and you going there and then choosing. Please understand, this is going to be enormous impact on the economic pattern. Enormous, because all these salesmen, hundreds and thousands of crores, are going to look for jobs. They have to unlearn and learn. Again, I'll come back to say, like ATMs and so on. The hundreds and thousands of people will have to unlearn and learn something new unless they can choose to be unemployed. Then I talk about AI, you realize that it's going to give rise to driverless cars, which is going to throw crores or lakhs of people unemployed unless you unlearn and learn. Because driverless cars, you don't need drivers. For buses and trucks and cars and so on and so forth. That will take 20, 30, 40 years. I mean, that's not going to happen immediately. But certainly, for a young crowd, I must warn you that in your lifetime, most of these things will take place. Now that's before 2000. Now what's going to happen after AI and Industry 4.0 is in fact far more exciting and at the same time frightening. I must tell you this because it is important that you understand what's likely to happen so that you will be better prepared for this. Now let me just talk about big data first. 3D printing, big data, IoT. I am going to introduce all these technologies in very such a short and sweet introductions, 2-3 minutes each. Because in order to sort of deal with them in depth, it will take time. But what is IoT and IIoT? IoT is in Internet of Things, which means in the house, all the equipment are connected through internet to each other in an intelligent fashion. An equipment can be dumb or can be intelligent. Intelligent, it has a chip, it has a program, microprocessor program, and it has embedded software. Normal software is embedded software. It's not the kind of software that we write and download it from a disk and then run. It is embedded by manufacturing. Embedded software basically between hardware and software in between. So it is etched on the chip. So you basically, microwave oven for instance, when you set a timer, there is a chip and there is an embedded software which controls the timing, the temperature and so on and so forth. Right? So all the equipment AC, all those which have chips which have intelligence therefore, that's the first thing. And then they are connected to internet, that's IoT, Internet of Things. So they can talk to each other. Case in point, I'm sure Amitabh Bachchan's advertisement is outside and from outside he checks, he starts the AC from in the house. If you remember that ad, he's outside somewhere and he wants to start the AC in his house. So he presses some button and then the AC starts. So that is because of Internet of Things. Through Internet he gives a command and the AC starts. Or a refrigerator, can check what is the stock of apples or bread and so on and so forth. And then when it diminishes below a certain level, the refrigerator through internet can actually place an order for the stuff. I'm just giving a couple of examples. So this is the Internet of Things for everyone that it is going to grow, especially in rich countries, it is going to grow enormously. Industrial Internet of Things is all the machines also are talking to each other. An example is in a car, a carburetor which is intelligent will start telling the driver saying that I am likely to pump off, I am likely to not work properly, so please service me, please replace me or whatever. And the driver go and actually tell the driver also the nearest garage address and maybe through Google Maps allows the driver to take the car to the garage. So that is IoT and IoT. What is 3D printing? 3D printing is earlier what was our printing has been subtractive printing. Like a sculptor uses a stone and removes the portion that he does not want to create a sculpture. Right? So it's subtractive. Similarly, earlier we used to take a piece of iron, aluminum, whatever, and used to use a lathe to remove the portion that you don't want to arrive at a piece that you want. That is subtractive manufacturing. With 3D printing is additive manufacturing, which essentially means that suppose you have to manufacture this bottle, So it's digital image. Digital image is stored in the computer, like you do in CAD, CAE, NC machines, the way you actually instruct the NC machines. The molten plastic, for instance, is fed to the 3D printing machine, and the digital image is used to construct layer by layer the substance that you want to manufacture. So it is not subtractive manufacturing, it is additive. So layer by layer actually it is manufactured. But this 3D printing is entering into just about every field. In many parts the dentists use today. They are manufactured using 3D printing. Many parts they use the airplane today are manufactured using 3D printing. In fact, 3D printing is advanced to such an extent that today a building is created using 3D printing. A temple is created using 3D printing. Direct, complete temple. So what will happen to civil engineering? What will happen to the builders? If tomorrow all these buildings and that's what most of the things could be produced using 3D printing, then it's going to change the manufacturing, even mechanical engineering, even civil engineering. It's going to have a tremendous impact. I'm not trying to say that everything could be manufactured using 3D printing, but quite a few things could be manufactured using 3D printing. That's going to change the entire field of engineering. What is big data? Big data is essentially data analytics Big data is not just the volume of data. Big data obviously has tremendous amount of volume of data. We create huge data, several terabytes every minute, every second. Hundreds and thousands of ECG machines and X-ray machines and so on and so forth all over the world. Hundreds and thousands of messages, SMS and WhatsApp of crores of people, for instance. All of several companies store data for employee production, purchasing and so on. All that data from satellites, data from... So if you put all that together, the entire data is big data. But what is the use of this data? Just because it is big. You have to interpret that data. What is intelligence? Intelligence is essentially pattern recognition. Actually, intelligence, there are several types of intelligences. In my book, Mana, which is in psychology, there are 6-7 types of intelligences. Musical intelligence, spatial intelligence, about space. Many architects need that intelligence. But commonly, when we mean by intelligence, even artificial intelligence, is essentially pattern recognition. You don't understand this. Remember this very, very clearly. Intelligence is pattern recognition. So in the data, when you recognize a pattern, that is essentially AI. When you take an IQ test, for instance, aptitude test, you say 1, 3, 5, 7, what is the next number? What is it? You are essentially recognizing the pattern, right? 1, 3, 5, 7. So there is a difference of 2 or whatever. Essentially pattern recognition is intelligence. Please understand. Now, supposing I give, there is a bank and there are lakhs of customers, and I give the data of lakhs of customers to a software and say, please find some kind of relationship between them. Now that data for each customer could be age, date of birth, the place, address, sex, years of experience, salary, whether one owns a car or not, bank balance, whether the fixed deposit or not, hundreds of things. Right? And all that data about each customer and lakhs of such customers is fed to the software. And the software is asked to find the patterns in relationship between data. This is called in AI parlance unsupervised learning. In machine learning or deep learning, there are two types. One is unsupervised learning and one is supervised learning. Unsupervised learning means that you do not tell what you want. You only say, please find any relationship blindly. Just provide data and find out, ask the algorithm to find out what is the relationship between data items. That is unsupervised learning. And I'll come to that supervised learning a little bit. Now supposing the algorithm goes through all sorts of data items and match. Is there a relationship between the height of the person and the salary? Obviously there would be normally, right? But machine doesn't understand. It matches all kinds of relationships between, it says out of lakh of customers, it finds out, takes height and takes salary, and then the statistics is a coefficient of correlation. I'm sure you know that. The coefficient is 1, then there's a very good relationship between the two. If it's 0, there's no relationship. So that's why statistics is very important for AI, for data analytics, for data science, and whatever. So it finds out whether there is a relationship between height and salary. It finds none. But after going through enormous amount of combinations and permutations, supposing it comes out with this result, that all those customers who have graduated and who are graduates and are MBA and have 3 years of experience are likely to buy a car with 80% probability. You understand? If that conclusion is arrived at, then the bank will give the phone numbers of these people with graduates with MBA, with 3 years experience, etc. And ask the call center to keep on calling them to find out whether they need a car loan and so on. So that's how it works. This is unsupervised learning. That is data analytics for you in very simple terms. This is data science for you. In data science, you essentially use the data to arrive at the patterns or arrive at some kind of results. In normal IT, we feed a program like payroll and we get data like basics. In artificial intelligence or data science, you feed the data and get the output as program or algorithm or pattern. That is, the whole roles are reversed. So that's why data becomes a king. More and more data you feed and more and more patterns of the data you search, then you learn a lot. That's why machine learns from the data. This is why machine learning. But this is unsupervised learning. You are not told, you ask the algorithm to find a specific relationship between height and this, etc. You just ask the algorithm to find out any relationship. That is unsupervised. What is supervised learning? In supervised learning, you tell the algorithm what to learn. For instance, you show the machine, the software, a picture of the cat and ask the software to learn how to recognize a cat. This whole idea came into existence when people said, can I replicate how our brain works? The brain has millions of neurons and they are connected through neural networks. Can I replicate that? That's how artificial neural networks came into existence. And in the artificial neural network, there are various layers of neurons, artificial neurons. The artificial neuron is a magnet or whatever, how it is represented in hardware, forget it. But there are various levels of artificial neurons. The levels are very high, it's called the deep learning. And deep learning is a part of machine learning. Machine learning is essentially learning from the data. There is finding out patterns from the data. There is a simple term. How do you do that? That's in simple terms. It doesn't happen that way, but just for you to understand. Maybe the first layer will look at the legs. And it says that there's 4 legs. It can be cat, it can be dog, it can be elephant. So it will pass on to the second layer, say that if the probability of it being a cat is 20%, a dog is 20%, etc. etc. The second layer may maybe look at whiskers. Third layer maybe look at eyes and so on and so forth. And each one by logic will conclude as to what is it possible. And the last layer will say the probability of it being a cat is 80%, a dog is 10%, etc. If it says that the probability of cat is 10% and the dog is 90%, obviously there is something wrong. Then there are mechanisms where the weights are changed and reverse logic takes place. I won't go into detail. I have explained that in my book. But I think the important thing is that it adjusts the weights, it adjusts the algorithm, the program in such a fashion that ultimately it recognizes the cat. So maybe thousands of times when you show a picture of the cat, it learns how to identify the cat. So the 1001st time that you show a picture of the cat and ask the algorithm to recognize what animal it will say it is a cat. You can do that for a cat, for a rat, for a dog, for a house, for a horse, for the elephant, for all animals, for all plants, or things like bottles and tables and so on and so forth. Hundreds and thousands of things you can ask, you can make the algorithm learn to recognize. And that has already been done. In driverless cars, how does the driverless car work? They make the car run through streets hundreds and thousands of times and it learns how to recognize a pole, how to recognize a signal, how to recognize a stone, how to recognize any obstacle and so on. And then obviously there are mechanisms by which if there is an obstacle, automatically the brakes will apply, will be applied, and so on and so forth. That's how the driverless cars work. But the point I'm trying to say is the supervised learning and unsupervised learning, artificial intelligence is growing leaps and bounds. Now, how does it help? I'll show you an example. Supposing take mouth cancer. With mouth cancer, a picture of mouth cancer is shown hundreds and thousands of times to the algorithm, and when a new patient's mouth is shown, the algorithm recognizes it as mouth cancer. But mouth cancer is maybe relatively simple thing. But supposing there is a ailment in which the blood, a specific thing, maybe hemoglobin is a particular level, X-ray will show a particular patch in a particular place, ECG will show something different, and all of these are put in digital by the way. All of these are digital. Imagine for 1,000 such patients with the same ailment, You are given data as input of blood reports and X-rays, MRIs and ECGs and all that with the same elements that you have provided the algorithm maybe of thousands of patients and ask the algorithm to learn how to identify that element. The machine will learn. If you do that for 5 important elements and then supply blood reports, ECG, X-rays, etc., it will match, it will find out and it will actually diagnose most of the cases. Obviously, it will not do away with the doctors, but the doctors will be provided with enormous amount of substantial help to diagnose. So tomorrow's doctors will be very different. Tomorrow's lawyers will be very different. In tomorrow's world, artificial intelligence is likely to create unemployment of 62% according to some estimates. Does not mean that you will be jobless, but you certainly, at least the nature of work, the way you do things will change. A sociologist has said that you have to change your job 6 to 7 times in your career. It does not mean that changing a job doesn't mean going from TCS to Infosys, from Bank of India to Bank of America. Changing the job means the way you do things. Like in ATM, you have to unlearn and learn. You have to unlearn and learn 6 to 7 times in your career. That's going to certainly take a toll on your psychological health and in allied things. So the point I'm going to make is, in tomorrow's world is going to be turbulent. I can't just go on, but I think, I'll probably take 5 more minutes. Then multiple things will happen. In tomorrow's world, things will change. There will be theatres, buildings, and we can from Pune to Solapur within 6 minutes and so on. I mean, all that will happen. The travel will be fast. Mega trains, which are already in existence in Canada, many other countries will take place. That's not the issue. The people will start living 120, 150 years. They will be bored as to what to do. 70, 80 years will live with them, maybe take a tablet, again sleep for 10, 20 years, maybe get up, then maybe start asking any new friends, any new hotels, any new restaurants, any new cinemas. Again enjoy for 10, 20 years, again drop dead for 10, the kind of life will be very different then. So, and this is not science fiction, this is likely to happen. If Abdul Kalam has said that there will be 3 T's in tomorrow's world: biotechnology, nanotechnology, and information technology. All those 3 T's will play havoc in tomorrow's world. The message that I want to give to you is that things are going to change, and that's why I started with the original universe. And the rate of change is so high that things will happen before you even notice it. So the message, that 2, 3 messages that I'm going to stop. What should you do in such a case? If the things are going to change so rapidly, what should you do? Point number 1 is that you should be very good at what you do today. If it's mechanical engineering, civil engineering, your fundamentals have to be very clear and very good. Point number 1. Regardless of this. If your fundamentals are good, you can uncheck, you can unlearn and learn very fast. If your basics are very good. People come and ask me whether somebody, myself, his or herself, should learn Oracle version, this and this. I said, forget Oracle version. Your fundamentals of computer science, operating systems, databases, and so on and so forth should be very good in the first place. Then you can learn very fast. If your fundamentals are not very clear, then you will be thrown to the periphery, into our world. The things are going to change so fast. If your fundamentals are good, you must certainly learn to unlearn and learn. Accept that, in fact, in IIT, when we passed IIT, we started asking questions whether we need to go to the first year again. Because things that then, now it's so much that by the time you become graduated, maybe 5-10 years in your career, things will have changed tremendously. So you have to accept that you will have to unlearn and learn all your life and continuously. Only those who unlearn and learn and accept new things will survive. By that I don't mean that the remaining will die hungry. That's not what I mean. But all I mean is, if you want to be at the center, leading things and driving things, you better unlearn and learn and be at the leading edge rather than at the receiving end and then somehow hang around, be thrown out from one company, and somehow take a course and then get a job somewhere else, again being thrown out somewhere else. So if you you have to lead and be at the center, then pay attention to what I'm saying, otherwise you don't need to. Third thing, you have to have a good personality. And by personality, most important is communication. You have to have excellent communication. In any language doesn't matter, whether Marathi, Hindi, English, whatever. Suppose you must have good English if you want to be, in modern world, because modern world is global and you come in contact with at least I did US, UK, Australia, etc. If you have good English, you look at that. I hate to give examples from my personal life, but I've been educated in Marathi medium in Solapur, and I certainly went to IIT in Mumbai. And in the first year, when I was sitting in the next table, somebody insulted me about my English, speaking English, spoken English. And I don't take insults very lightly, intellectual insults very lightly. Somebody says you're not good looking, somebody says you don't have money. I don't mind if somebody speaks the truth. If somebody says you can't do a particular thing, then I used to feel very bad. For the next 10 months, I did nothing in English. I've been educated in Marathi medium, please understand. For the next 10 months, I did nothing in English. Etymology, that is roots, that is phonetics, that is pronunciation. And it's not just, the first thing I decided is very important. I decided I will not think in Marathi, translate and then speak, which is what most of the people do. I said, I'm not going to do that. I should be able to think in English. My English should be so good that you should be able to think in English. Not think in Marathi, somehow translate, somehow just babble. That's a very bad way of communication. I said, I'm not going to do that. Whatever you do has to be excellent. So research for excellence is very important. So I said, for the next 10 months I read several novels. I did hundreds of things. I used to stand in front of mirrors and practice speaking and so on. All that came handy when I gave several seminars and workshops in New York, London, Sydney, Tokyo, etc. So your communication has to be good. You have to bring home your point. You have to be persuasive. You have to be elegant. You don't have to somehow speak, and that's not very good. If you want to succeed, if you want to get the periphery, do whatever you like. Then you have to be a good listener. You have to be patient. When I used to take the interviews of several ladies and general managers, whatever, I used to entry level people, used to give a topic for group discussion, and people used to talk about the topic. And most of the people used to be aggressive in being the first one to express what they wanted to. Whereas somebody used to listen to all and then ultimately thinking about what he wanted to say, he used to put forward his or her viewpoint cogently, emphatically, and very clearly. And I used to choose that person. So a good listener, thinking logically, think positively, and then come to a conclusion and speak. Good listener, right? This is very important. Thirdly, teamwork. You can't be a loner today. You cannot be a loner. Gone are the days when Newton sat under the apple tree and thought about gravity. You can't do that. Don't sit under any tree, nothing will happen. Today, everything is teamwork. I have several friends in MIT, Stanford, Berkeley, etc., on TI for IIT, for working on important for abstract subjects as Big Bang and quantum physics and string theory and so on. But they all work in teams. I communicate with a Japanese colleague is what I have found. That person communicates with my colleague in UK and so on and so forth. And they work in teams. In software projects, there are teams which actually execute the project. In pharmaceuticals, you are given a target, this 40 people team, and you are told to find a molecule or diabetes new molecule which will bring to the market in the next 4 months or whatever. So you are given a deadline, you have a target, it's a teamwork. Today without teamwork, nothing is possible. So you have to be a good listener, you have to be a team worker. You can't be an egoist and egotist, there's a difference. You have to go into. But the egotist is the one who speaks much about himself. Egoist is only selfish, speaks about it. So you can't be an egoist and egotist to think very highly only about yourself and be dominating. You have to accept, you have to cooperate, you have to be a team worker, you have to be a good listener, you have to set your executive, you have to lead by examples. You have to lead by example. You have to set examples of leadership. So these are the very important qualities. Next is that don't only look at employment. Think about the people start something on their own. And the last but not the least, it is very important that you're studying here, you're very lucky. Because 50% of India is underprivileged. Their houses don't have electricity. Water is a big problem. They are not as lucky or fortunate enough to come to the institute as good as this. They can't take education. The healthcare is a big issue. So think anytime you succeed, you go to America, you succeed, you make money, whatever, but think always about how the other half lives. And think about how we can work to bring the entire population to a level which is very good and humane. If you do that, you not only be a successful individual, but also a good individual. And that's what we should strive for.